functions. These are some graphs that you're going to have to be familiar with moving forward. You have to know what these look like. So we're going to start with the one y equals x. And what it's asking us to do is fill out the table below. So if I plug -4 in for x, and then I solve for y, I get -4. If I plug -3 in for x, I solve for y, I get -3. This one's a pretty easy one, so that's what keeps happening. So now I'm going to graph those tables, and I'm sure you're familiar with this y equals x equation, but let's graph those points on the axes here. So we got -4, 4, -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So when I sketch this graph, you get this line that passes through a y-intercept of 0 with a slope of 1. You've got to recognize that graph as y equals x from now on. We have to know what that looks like. Okay. Now we're also going to learn a little bit how to use our graphing calculator here. So let's take a look over here and see how we use our calculator. So this is your home screen where you guys are typically doing some calculations, something like 8 times 5, right? Now we're going to focus on these buttons for graphing up here. So when you want to graph something on your graphing calculator, you're going to go to y equals, and you get all these equations that come up, these y1s, y2, y3. Those are subscript, y sub 1, y sub 2, in case you want to graph more than one equation. So we're going to graph the equation y equals x. So this button here is where you get your variable, y equals x. And now again, these buttons up top are the ones that will help you graph. So you're going to hit graph, and you can see there's our equation, the line y equals 1, which matches our answer. So we're good. We have checked our answer on our graphing calculator. All right, let's move on to number 2. Now we're going to look at the equation y equals x squared. So we're going to fill out the table and then graph and see what's happening. Now remember, when this is really important. When you plug in your x value, it has to go in parentheses, and it matters in this function tremendously. So let's look at the first two. What do we get when we plug in -3 and we square it? Well, we know that squaring means -3 times -3, which is 9, and -2 times -2 equals 4, because a negative times a negative is a positive. Let's look at when we use our calculator over here, just to do some calculations. If we do not use our parentheses, so when I plug -3 in for x and I want to do -3 squared, we're getting an answer of -9, but we know the answer is 9 because -3 times itself. Why is this happening? Well, what the calculator is really looking at this as, when you put -3 squared without parentheses, it's really looking at it as -1 times 3 squared. So it's going to do, by order of operations, it's going to do the exponent squared first and then do the multiplication by the negative. So when you have just a negative sign out front, the calculator is interpreting it as -1 times this. So this would do 3 squared first and get 9, then do 9 times -1. That's why you're getting the -9. If you want the calculator to do what you mean, like -3 times -3, that's what -3 squared is, right? This is what you want the calculator to interpret your -3 squared as. We know -3 times -3 should be +9, which is what we get here. So how do you make the calculator do that? Whenever you're squaring a number, you need to put that number in parentheses, especially if it's negative. Now the calculator will interpret this properly, versus here where it interpreted it incorrectly. It interpreted what you didn't want it to do. Here's how you make it square a negative number. It's got to be in parentheses. Now you can see that when I square that, I get +9. Okay. So now if I want to square -2, I've got to put it in parentheses. And I get 4. All right. So whenever we're plugging x into our equations, we want to use parentheses always. So now when I plug in 0, I get 0. So let's start filling these in. When I put in -3, I got a 9. When I put in -2, I got a 4. -1, I got a +1. 0, I got a 0. Now if I plug in 1, 1 squared is 1. If I plug in a 2, 2 squared is 4. If I plug in a 3, 3 squared is 9. So I get the point negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. So the shape that I get makes like this U-looking thing. And we call that a parabola. You may have seen this already in Algebra 1, or you might have seen it in middle school. That's called a parabola. This one we should say this is a line, right? And so now you need to know that y equals x looks like this, and y equals x squared looks like this parabola that has a vertex, okay? Just some words we want to know. A vertex at the point 0, 0. And that's kind of our key point we're going to need as we work with transformations to these guys. Let's check our answer on our graphing calculator. So we want to make sure we graph this correctly. So we're going to go to y equals, and I'm going to go down to y2, and I'm going to graph x squared. Y equals x squared. So when I hit graph, you're going to see y1 is already there, but then they graph y2 in red. So it looks like we got it right. We have our parabola. Now let's say you don't want to see the line. You could delete it here, or you can go over and highlight that equals sign there, hit enter, and it will just turn it off for a little while so that you can go look at the graph later if you like. So when I hit graph, you'll see the line is no longer there. We just get our parabola with the vertex at 0, 0. Let's move on to the next one. Now we're going to look at the absolute value function. Y equals the absolute value of x. Remember that absolute value turns any number positive. So when I plug in my negative 4, I get 4 because the absolute value of negative 4 is 4. It just makes it positive. So then when I plug in my negative 3, I get 3. And when I take the absolute value of negative 2, I put 2. Now, why am I not using parentheses here like I said before when I plug in an x value? Because the absolute value symbol actually acts as some parentheses. So then the absolute value of negative 1 is 1, 0 is 0, and then 1 is 1, 2 is 2. So what does this look like when we graph the absolute value of x? Negative 4 is here, negative 3, positive 3, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, 3, 3. This is a weird one. It looks like a V it makes. It looks like the line y equals x, except it makes a V instead of a straight line. So it is related to y equals x. It looks just like it. Remember, absolute value means make all your negative values positive in terms of your y values. So what this graph really is the line y equals x, but all of these guys here, all of these values, these y values are all negative. And since we're taking the absolute value of a negative, it's going to take all those negative y's and it's going to make them positive. All right, and that's why we get a V here for absolute value. So you can think that absolute value was really the line y equals x, right? It looks just like it, but the absolute value here is going to reflect that negative part up above here. And you could, with an absolute value function, you just can't go below the x-axis. You can't get negative y's. All right, so that's what that looks like. Let's check our answer on a graphing calculator. I'll cancel that update. Great, so you didn't see what I was just writing. Let's try that again. So absolute value looks just like x, because what I was saying was, if I take my absolute value, says make your negative values positive, all your negative y's. So that negative y will pop up here. Your negative y's will become positive y's, and that's why you get this V shape. So it is closely related to y equals x. So if we look down here, I want to get rid of this and just have the proper graph here. Okay, if we look down here at our absolute value, like before it's an absolute value, you can think it was line y equals x, but then the absolute value takes all these negative y's and makes them become positive. so it reflects them over the x-axis. That's where it comes from. Let's check in our calculator, see if we got it right. So first I want to turn off my x squared function, so I go to the equal sign and hit enter, and then I can go into the next line by hitting enter, and I want to do absolute value. I'm pretty sure it's in one of my alpha menus, so I hit alpha and I go up here to F1, nope, F2, I see number 1 says ABS, that means absolute value. Now if your calculator doesn't have these alpha menus, you can also find it under the math button, I think. No, it's not in math. Oh, I was in second, so it is in math. It's in math. When you hit the math button, this menu will come up. And let's see what menu it's under. You go over to the number menu, and the first one is absolute value. So you can find it there as well. These alpha menus up here are just shortcuts to some common things that we use. So alpha F2 has the absolute shortcut as well. All right, so let's go back to our y equals. So here is, I want to quit out of this. Go back to our y equals. So here is our absolute value. So we want to go down to that, and we want to put an x in there. And we'll hit the over arrows just to make it look right. There's the absolute value of x. We want to graph this thing, and there we go. We get our kind of V-shaped graph. So we got it right. Let's take a look at the parent function y equals the square root of x. This one is a version of our parabola. We had this like U-looking thing. The square root of x, well, squaring and square rooting are inverses. So the square root cancels out the square. So it's not going to mean much to you yet. You don't have to understand this part yet, but the absolute value is going to be like a sideways parabola, but we're only going to take the top part. So it's going to end up looking something like that. But that's how you could remember it. It's like a sideways parabola because square rooting, right, that symbol, square root, is similar to squaring. It's like the opposite thing. So that's how you can remember it. We're going to actually kind of show that it's that. So what happens if I put a negative value in here? What is the square root of negative 2? That means what times itself is negative 2? There is no answer. We call that undefined. So there's no graph at negative 2. There's no way you can multiply a number by itself and get a negative answer. So there's no square root of negative 2. So let's move on to negative 1. Same idea. There's no answer. We call that undefined. Any negative number, so all these negative x's over here, there is no graph. The graph starts for the first time at y equals 0. What is at x equals 0? What is, so if I plug in 0 for x, again, I don't need parentheses in this case because the square root itself acts like parentheses. Okay, but I'll put them in there anyway. What is the square root of 0? What number times itself equals 0? That is 0. If I put in a 1, that means the square root of 1. What number times itself equals 1? Well, that's 1. If we go to the square root of 4, we're going to skip ahead to 4. What number times itself equals 4? That's 2. And then if I plug in a 9 for x, we're asking what number times itself is 9, and that's 3. So let's go graph these points. We have the graph just sort of starts at 0, 0. We won't call that a vertex, but that is an important point. I'll just call that a key point. It's sort of where the graph starts. We have 1, 1. Then we have the point 4, 2. So we'll do 1, 1. Then we've got 4, 2. And then we've got 9, 3. And you can see we start to get that sideways parabola like x squared. But we don't have the bottom part, just the top part. Okay, so let's check our answer on a graphing calculator. So we go to y equals. I'm going to turn off the absolute value function. So I'm going to go over here to the equal sign, hit enter and toggle it off. And I'll go down to y4. And now I'm going to graph the square root. The square root is above the square since these are inverse functions. They undo each other. I hit second, x squared. I'll get my square root. Hit my x. So now I have the square root of x. I graph it. And there it is. That's my sideways parabola there. Maybe it's good to look at x squared here for a second and see how it's the sideways version. So if I go to x squared and I turn it on, that'll be the red graph, because you see it's got a red next to it. You can see it's like the sideways parabola version. Like that's the parabola. The pink one is the sideways parabola, but it just doesn't have the bottom part. Whoops. So let's turn that off. And let's turn our square root 1 off as well. All right, let's move on to the next graph. They want us to graph 1 over x. So here, I'm going to plug in a -3 for x, and I get -1/3. You can think of that as 0.3 repeating if you like. Now when I plug in -2, I get -1/2. You could think of that as -0.5 if you like. If I plug in -1, I get 1 divided by -1 is -1. If I plug in -1/2, -1/2, this is the interesting one. You're actually going to get -2. Why is that? Let's look down here for a second. If I have 1 over -1/2, you're dividing fractions. So what you want to do is you want to say 1 instead of, we can call 1 over 1. And instead of division here, we change the sign and then we multiply by the reciprocal. So if we flip the 1/2, we call it 2 over 1. And when we multiply fractions, we now multiply the tops. That was a -2, right? I kind of covered it up. And then we multiply the bottoms. So that simplifies to -2. So this is a -2. If I plug in a 0 for x, I cannot divide by 0 in math, just like I couldn't square root a negative. So I'm going to get undefined. There is no y value when x is 0. Now if I plug in 1/2, I'm going to get 2 for the same reason up here. I got -2. I'm going to get 2 here. If I plug in 1 over 1 is 1. If I plug in 2, I'm going to get 1/2. You could think of it as 0.5. And if I plug in 3, I'm going to get 1/3. You can think of it as 0.3 repeating. So let's sketch a graph of this function. We've got -3, 1/3. So that's kind of really small. Whoops. It's -1/3. So I've got -3, -1/3. -2 is -1/2. -1 is -1, and then -1/2 is 2. So what's going to happen with this graph, you might not catch it, but it's going to make this curve here, and it's going to just keep going down like this. It's never going to really touch these lines. These are called asymptotes. And it just approaches them but never touches them. Okay? So that's what that side looks like. The other side, 1/2, 2. Get rid of these. They're a little bit in the way. So if I go over 1/2, I go up 2. Then I've got 1, 1. Then I've got 2, 1/2. Then I've got 3, 1/3. This graph will sort of do the same thing over here on this side. Never touching them. Something to note. Notice that the x value 0 has no y value. If I go up, I never hit the curve. If I look down, I never hit the curve. So 0 has no y value because you can't divide by 0. So that's what the graph of that looks like. You need to know that 1 over x looks like this funny thing here. Let's take a look in our graphing calculator and verify our results. So I want to say, if I want to make a fraction, you can use that alpha menu again. And you want to choose number 1, right? That makes a fraction for you. If you don't have that alpha menu, you can just hit the division symbol, and that will work. So that's 1 over x. We graph it, and we can see we have that graph there of what we drew. Let's do our last one. And by the way, these extensions, we'll do these in class if we need to. I'm going to leave this to you. We'll go over this in class. You need to finish this one on your own. Make sure you check your answer on the graphing calculator.